Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, today we are going to get started with a challenge quiz on electrostatics, and post that we'll also have a lecture on electrostatics, so don't miss it out. And do remember, don't challenge your limits, but don't limit your challenges, but challenge your limits. So make sure you're not limiting your challenges, you are ready for the best of the challenges, and today we are going to have it. And students, that being said, students who don't know me, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university, and I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And guys, today, yes, the quiz is already hosted. You can quickly join the quiz. The code is going to be 395194. Okay, you can join the quiz now, and we will wait for 5 to 6 minutes. And yeah. So yes, guys. So we will not be parallel. I will be giving hint. We would not be able to parallelly be running the solution or writing down the hint as we were thinking earlier, because the reason is it often hampers the performance of the video, and we would not be able to do that. But you can join the quiz now, and I'll give you a hint, and I'll try to if mentally possible, I'll try to solve them along with you, and it's going to be interesting, I believe. Yeah, you can join the quiz quickly, guys. Quickly, you can join the quiz. So yeah, how do you join the quiz? If you're totally new to this, all you need to do is like download an Unacademy learning app from your Google Play Store and App Store, and post that. What you need to do is, guys, click on the left hand top corner extension bar, choose plus, and then you need to first of all log in and then choose plus. Quiz is free of cost, and on the bottom you will have test tab, and then you can click on the join quiz button. Just enter this code. The interface might have changed a bit, so you may want to go according to that. So yes, join the quiz, students. Join the quiz and make sure you're attending the quiz along with me, because it's going to be a very interesting quiz. So the code is 395194. So yes, today we'll be having around 20 problems, 80 seconds each, and each of the problem is going to be related to electrostatics, of course, as you know, and we'll be dealing with the easier part of electrostatics today. Since the first quiz, we will have an easier part of electrostatics as a part of the quiz. Oh yes, students, yes, you can join the quiz. Do join the quiz. It's going to be a short quiz. Alright guys, we'll wait for another 5 minutes. The code is 395194. Let me do a thing. So we won't be switching to PPT, but you know what? I can quickly just note down the code so that you have it for your slowing down. Just bear with me for a moment, because if someone wants to join in between, we can make use of quiz code 395194. Okay, right. So yes. All right, guys. Think we have 2 more minutes. Join the quiz from Unacademy Learning app. I think don't have any participants for the quiz yet. So next 3 minutes we'll be terminating the quiz. Two more minutes and 20 seconds will be terminating the quiz. So I believe it's already 7:45. Okay, 3 more minutes. We'll wait for 3 more minutes. I believe there was a little late start due to some issues with. Alright, we already have one participant, one more participant, and 3 more minutes. We begin the quiz. We would not be waiting anymore. So, but yeah, guys, if you have been attending electrostatics, this is going to be very useful for you. So you don't want to, miss out such quizzes. Yeah, typically, when we have two participants now, and a little bit more, if we'll have more participants, 2 more minutes, we'll begin the quiz. We already have 10 minutes since the beginning of the this. So yeah, students, it's already 7:47. So we'll wait for 2 more minutes and see if we have any 1 or 2 participants joining in. Do join in, do call your friends. It's 395-194. So do share this code. You can just share this code, and you can invite your friends as well. Do invite your friends. So yeah, make sure you have your friends on this quiz as well, because it's going to be a very interesting quiz, guys. No other reason. We have a lot of PYQs and model problems like what you can expect in your JEE Mains and JEE Advanced. So 1 more minute. Anyway, we have the quiz code. If anyone wants the code, I'll post it out. It's 395-194. And yeah, the quiz will begin in 60 seconds from now on. So anyone who wants to join, you can join now, else we will get started with the quiz. Right. Oh yes, 30 more seconds, and I believe we'll be getting started with the quiz. So up until then, students, even if you're watching this video, Try to attempt the questions, that is more important. Uh, but try to attend the quiz so that you have the track of the time as well. So that's also very important because it's a competitive exam ultimately, right? So you need to have track of the time. That is also very important. All right, guys, it's time to begin the quiz. So 5, 4, 3, 2, 1, the quiz begins. All right, now let's get started. So very easy question. 2-point charges plus 9e and plus e are kept at how much? 16 centimeters apart from each other. Where should a third charge q be placed between them so that system is in equilibrium state? System will be in equilibrium state if the force on the third charge is 0. Okay. What are you going to do that? Q1 Q2 by R square is equal to, in this case, Q1 by R square is equal to Q2 by R square, and distance between them is 6. One of the R is going to be X, other is going to be 16 minus X square, isn't it? So you are going to have 19 divided by 9 divided by X square. Let's take distance from 9e as X. 9 divided by X square is equal to 1 by 16 minus X whole square. Take it as 3 by X. Okay, then you will get something like 3 into 16 minus X is equal to X. So that it should be, you should be able to calculate it using your pen and paper. I believe I wasn't able to do it just through words, but still fine. Alright, let's move on to the next question. Anyway, it's a balancing of charge. This was like the first topic that we got started with, like simple one. Alright, we have two positive ions, each carrying a charge q, and they are separated by a distance d. If F is the force of the repulsion between the ions, the number of electrons missing from each ion will be how much? E being the charge of an electron. So both of them are carrying charge q. Think about it carefully, where we have two concepts involved in them. What are the two concepts? One is, of course, Coulomb's law, F is equal to Q1 Q2 by R square, and they are separated by distance d. So you know how to find out value of q. Okay, first thing you have is like q, and of course the answer cannot be over here. It cannot be A and D, since you must have under root thing. So you have like F is equal to 1 by 4 pi epsilon naught, and 4 pi epsilon naught goes up, and E should be on the bottom, should be C, right? Alright, that's my answer. Anyway, I don't have a pen and paper. So, alright guys, let's move on to the next question then. So, yeah. Really, that was a simple question. So now we have a very interesting question, guys. So what we need to do, an infinite thread of charge density lambda lies along a z-axis. The potential difference between A and B are given to you. A and B is like 4, 3, 4, and B is 3, 4, 0. Is how much? So we are not dealing with we are dealing with electric potential, and this is infinitely long thread along z-axis. So the field would be in like two directions, of course. And how do you work around this kind of problems? You take either like you can take a Gaussian surface and find out the electric field, and then integrate it to find out potential. We have done a very similar problem earlier, if you remember. Or else you can take sigma by epsilon as electric field, and then do E dot dx. That's one of the easiest ways to do or deal with such kind of problems. So okay, this lambda, I'm sorry guys, this lambda is not sigma, this lambda, this one thread So yes, so that is the way you would go about it. Alright guys, let's get on to the next question then. So a moving charge 20 Coulomb by 2 centimeter and 2 joules of work is done. On moving a charge of 20 Coulomb by 2 centimeters, a 2 joule of work is done, then the potential difference between those points is how? So Q delta V, you know how to do this. Q delta V is equal to the work done. Okay. Now 2 joules is what the work that you had to do to move this 20 Coulomb charge by 2 centimeters. Right? Work done is 2. 2 is equal to 20 delta V. And how much do you have? 1 by 10. So it should be how much, guys? 8 volt, 2 volt, 0.5 volt or 0.1 volt. Should be simple one, guys. It's a very simple one. We also discussed about the conversion factor. Good. Alright guys, let's move on to the next question then. A hollow metal sphere of radius 5 centimeters is charged as that the potential on its surface is 10 volt. And the potential at the center of the sphere is going to be how much? It's a very interesting question. We have recently gone through this lecture, didn't we? At its center, okay, we haven't started with this part. Or did we do? Yeah, we did this part, right? We did this part. This is not a big deal. Yeah, we have done this part. So it's a hollow, okay, it's a metal sphere anyway. It's a hollow metal sphere. So what should be the potential? Is it going to be 0 or is it going to be 10 volts? It's going to be the same as that 5 centimeters away from the surface. Guys, come on. This is something, you know what, you can quickly mark it, right? I'm not going to mark it right now. I'm going to mark it 3 seconds so that you're going to watch me later. But before 5 seconds, this is a conceptual question. Metal sphere, potential on its surface and potential inside anywhere is the same. The potential on surface, if it is 10 volts, what is the potential going to be at the center? At any point inside, it's going to be 10 volts, isn't it? I think it's slowing down if I'm answering it. Is it? Alright guys, alright, try to do it on your own. I can't mark the answer, I guess. There is a little bit of lag that is coming up. Alright, we are on the next question. So in a certain region of space, the potential is given by V is equal to K into something. Okay, we'll do a thing. We'll take up this problem today and solve it as well. Because the reason is we need to do this part. We haven't done earlier. So, but how do you do this kind of question, guys? You're given a potential. You need to find out electric field. Electric field, you have to do a partial differentiation now, right? Because x, y, z is given to you. You need to do partial differentiation with respect to x, partial differentiation with respect to y, partial differentiation with respect to z. And its potential, it's just a scalar quantity. Keep the k outside anyway and start working around it, right? I think there is a root in this somewhere. So at electric field at point 1,1,1 is being asked. dV by dx I cap plus minus of dV by dx of I cap, so on you'll go. Good. So yeah, in such questions you need to do partial differentiation, students, and under root you would see because magnitude of electric field is B. Okay. So a sphere of charge R and Q is placed inside an imaginary sphere of radius 2r whose center coincides with the given Q by epsilon naught sphere. Okay. The flux related to the imaginary sphere is. Think about it carefully. What would be the flux? I think there is a blunder in this question. In a way, the answer is given to you, isn't it? So, a sphere of radius r and charge q is placed inside an imaginary sphere whose center coincides with the given sphere. The flux is going to be how much, guys? What does the Gauss law say? The Gauss law says charge enclosed by epsilon naught is nothing but flux. Simple question, isn't it? Don't have to think much. It's basically, I don't want to mark the answer. If I mark the answer, it's going to get struck. It's Q by epsilon naught. The answer is given to you in the question in a way, you know. Q by epsilon naught is present over here if you have noticed it. But this is basic definition of Gauss law. See, this kind of quiz trains you around, the things that you want to learn for your JEE Mains. That's the beauty of the quiz. So we'll take up that dv by dx problem anyway. Actually, we have another such question. This is even more interesting, you know. Why this is even more interesting? Because you have multiple variables. Okay, this is actually 80 seconds. It's little. It's going to be a little stretch for many of us. So yes, you have to do partial differentiation and add up. Okay, so let me quickly take you through the solution. So it's 3x square y plus 5y square z plus 7z square x. In x only these two would be appearing. One would be like 6x y, and here you would see 7z square. That is the x component. Okay. So you would have to substitute the value 3 to 1 and get the x component. Similarly, you will get the y component dy. So dy you will have two of them. And similarly dz. I don't think I can do it mentally, but let me just give it a try. But I hope you understood the problem, right? So this would be like 6 into 2 into 6 into 3 into 2. That's going to be 18 plus 2. 18 into 2, 18 into 2, 36, and here you would have like something like 7, 36 plus 7. So that itself came out to be like 43. That is I cap. If there is j cap, k cap, you would have to do it. I don't know. Just rocket. When is JEE 2021 going to happen? I don't know, students. But I believe it would be delayed a little bit due to COVID-19 situation. It would be delayed a little bit. So don't worry about it. Don't worry about it in a sense. Don't worry about how it is going to be delayed. Focus on your preparation. That is more important to you, right? So we are on to the next question. For spherically symmetrical charge distribution, electric field at a distance r from the center of sphere is given to you as k r to the power 7 r cap means radial direction, and where k is a constant. What will be the volume charge density at a distance r from the center? Not yet, human being, not yet any crash course. We'll do a crash course. We'll do a revision series before your JEE Mains, JEE Advanced. So I'm planning to pick up the topics, guys. So what is my plan for you? So I'm planning to pick up topics that would be, more kind of, I wouldn't say like more scoring in a sense. Now electrostatics is being done. Typically electrostatics, current and electricity, and whatever topics has been covered in my classes, if you cover them, you'll be able to attend 50% of your paper. So that's my objective. So probably I'll be taking up, like nuclear, etc. What we can do is we can do a revision around the same, because you can't be dependent on formulae for your exam. So anyway, this question there was, I didn't notice it. Okay, yeah. So like there would be like few concepts that we can go through in terms of revision, but let your exam date come out, then we'll do something like that. We'll take up concept by concept and maybe just take up a problem around the concept and solve it. So that way, that alone would take like 2 months and odd, I guess. Anywhere we need 80, 90 lectures. So I think more practical thing would be to choose such a topic from which you will get the most questions. So you are able to maintain the completeness, because you can't just move by formulae, guys. Okay, so that is the issue. Right. Okay, let's read this question. It looks very interesting. It's given in two languages. One is Hindi and in English. A small uncharged metal sphere is suspended by a long non-conducting string in the region between two vertical conducting sheets of opposite charges. The sphere is released from rest to a sheet as shown. Identify the correct options. So this is a reasoning based question, I guess. So due to electrostatic induction, the sphere will become a dipole. Will it become a dipole? Absolutely, absolutely. Okay. There is a lot in electrostatics, human being. Okay, who are your students? So there is a lot in electrostatics. My objectives, we have already done capacitors. So if you cover electrostatics, you will not be left behind. And electrostatics is not just about whatever concepts you are doing today. Today, if you come to the class, you'll notice, the way we deal with the problem is going to be different for your JEE Mains and JEE Advanced. That is true. The reason everywhere electrostatics is being done is the heavyweight topic. Electrostatics, current and electricity, magnetism, capacitor. These four topics combined together anywhere, you can bag 30-35% of your paper. Similarly, mechanics 40% of your paper. So that is the reason everywhere you would see this. Rest of the topics can be easy. Like optics can take anywhere around 2 months. The same, not the same amount of time, but less. But you'll get 2 to 3 questions. If you cover current, electricity, electrostatics, etc., you'll get anywhere around 30% of the paper, sometimes 10 questions, sometimes 8 questions, 7 questions. That's the reason you have this. SHM we won't do. We'll start with thermal physics. Okay, we'll start with thermal physics, and we'll probably start with nuclear. Very important topic according to me. Last year nuclear was less asked. This means I'm expecting that the nuclear will spike up. And okay. Anyway, I hope you're reading the question. We'll take up the question from the next one. Still, I can see the video to be little stuck. Let me quickly do a thing. Just a moment, guys. Okay. So yes, students. So I think it is best we start with the heavyweight topic, or we'll take up something like. Sorry for your JEE Mains Advanced. Okay. A particle of mass m is and charge minus q is projected from the origin with a horizontal velocity v into guys, a temporary blankout you must have seen. It is because I'm just trying to clear the memory for your video. A particle of mass m and charge minus q is projected from the origin with a horizontal speed v in an electric field of intensity E directed as shown in the figure. Okay, the kinetic energy of the particle after y displacement is how much? Think about it carefully. So along x your particle is moving, and how is your electric field acting? So what is going to happen? No impact on one side. Alright, awesome. Good. Amazing, 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 guys. Alright, then we are on to the next question. Alright, this looks like a previous year JEE Mains question. So stay attentive and try to solve it, students. That's the key part. So uniformly charged non-conducting sphere having charge q and radius r is kept in a gravity-free space. Something very favorable for you is given. So two identically charged particles are released from rest simultaneously from A and B. The speed of one of the charged particle when the separation between them is large is something like given as okay, the speed of one of the charged particle when the separation between them is very large is how much is being asked, I guess. Okay, this is so let me quickly grab the figure. Okay, there is a charge sphere and now you have Q and Q. Now the thing is what is the velocity of the speed of one of the charged particles when separation between them is very large? So you would not consider the effect of one of the charges, and you will only consider effect of the sphere. Okay, good. Alright guys, let's get into the next question then. So a Q charge is uniformly distributed over a square plate of area A, and another point charge is placed at a height A by 2 from the center of the square plate as shown in the diagram acting. So what is the force acting on it? Simply guys, simply don't put in much effort. Always do the thing that we used to do. How would you do this question? Go by Gauss law. Okay, it's not infinitely long, right? It's okay, it's a constrained plate. So not this thing. Now you can't go by Gauss law. You can take each small element to be a ring, solve it. Definitely do thing. Not A, it should. Alright, let's move on to the next question, then we'll have a look at this question. Alright. 4 identical charges are placed at the 4 vertices of the square lying in YZ plane. A 5th charge is moved along x-axis, which passes through the center of the square. The variation in potential energy along x is going to be how is it going to look like? What is potential at a point x? What do you think? It's going to add up, right? Okay, YZ plane is going to add up. That is it. Simple question, guys. So as you are moving a distance x, what is going to happen? And where would the minimum or the maximum energy be? Move on to the next question then. So we have reached near about 15 questions. What happens to electric flux when you so what is electric flux? Oh, sorry, this is not the answer. This is also not the answer. Anyway, I didn't want to mark the answer, but Okay, let me explain you the question. This is a conceptual question. The given figure, the net electric flux through an area A is something something. Like they are calculating it around the ring. So what happens when you immerse this system in some water or any other dielectric medium? When you immerse them in a dielectric medium, electric field lines are imaginary field lines, which is describing the strength of the field, right? So they would decrease. So that means electric flux will also decrease. I think just slow down. Let's move on to the next one. Alright guys, let's move on to the next question. That was a very simple conceptual question, but yeah, you can expect these kind of questions in your exams as well. Alright, we have another amazing question guys. A square of surface L, again electric flux related question, so it should be simple and move quickly in it. It's a uniform electric field, and a square surface of length L meter in the plane of the paper is placed in uniform electric field E acting along the same plane at an angle theta. Okay, so it is at an angle theta with the what? With the horizontal side. Oh, it's not. Oh, the horizontal side. Okay, just a moment, guys. Let me have a look at the question in my mobile phone. It's a little easier. A square surface of side L meters in the plane of the paper is placed in a uniform electric field acting along the same plane at an angle theta with the horizontal surface of the square. Okay, it is acting at an angle, so it should be either EL square cos theta or EL square sin theta. The thing is not definitely 0. I think it is cos theta. But I think it was at an angle theta with the normal. Alright, let's move on to the next question then. Okay, this is an easy one. We have done similar question. No, not yet, but this is a very famous question, guys. This is a very famous model problem. You try it on your own. N drops each charge to V potential coalesce to form a large single drop. The potential drop of the big will be how much? What do you think will happen to the potential of the large this thing drop? Think about it carefully. What do you think should be there on the n power? Think about the n power and think about whether it will increase or decrease. Kq by r, right? Initially kq by r is v. Now what happened? You made a like n number of this thing. It should be 2 by 3 into v into n and 3 by 3. Okay. So yeah. Conserve the volume. Good, very good. Is it? But again, the same question, I guess. This is again a conceptual question. The same question. It decreases. Really simple. Just move on. Alright guys, this question, if you can attend it, just attend it. It's the same question, I guess. I didn't notice this. Yeah. So, simple one anyway, but a very good concept. What happens on immersing in a liquid? We generally study flux is equal to Q by epsilon naught, but rather it's Q by epsilon, right? So number of electric field lines decreases. Simple. Electric flux decreases. You can think about it of that way, right? Dielectric medium, number of field lines decreases. So yes, students, stay tuned. We'll be getting into the lecture as well around electrostatic potential. Going to be a very interesting lecture. Alright guys, alright. So we are on the last question of the day, and there you go. So what it should be? So now be EL square cos theta or EL square sin theta? E dot A, right? What is the area? L square. Electric field is uniform. Now E dot A, what is the theta is the thing that you need to know. Then it is told to you it's acting at an angle theta with the horizontal surface, so it should be EL square. I thought the question was confusing. Good, amazing guys, amazing. So yes, we have the leaderboard over here, and yeah, so I wanted to take up one of these questions. So of course, we will be having a look at it. Which was that one? Yeah, we already dealt with the concept, but we never solve the problem around them. I'll take up one of this problem and we will start solving it. We'll begin the lecture from here, and we as well have a question from Suraj. I'll take up the easier version of it. This version you can do it on your own. So basically you need to do partial differentiation and add it up. I will do a thing because this version will take a little longer. Let's take up the easier one of it. So we are given like a potential V is equal to K into 2x square minus y square plus z square. Okay, I'll just take up this question. I'm going to close this up and I'll find out the electric field on the before the start of our lecture. Alright guys, V is equal to K into 2x square minus y square plus z square. Alright. Oh, yes, let's get started with the lecture then. So what were we given? So I'll just quickly take you through the method to solve the problem. So the question was, we have already dealt with the concept, so it makes more So given to us, I think V is equal to K into 2x square minus y square plus z square, something like this was given to us. Find, so the question is, find electric potential at point 1, 1, 1. Find, electric field at the point 1, 1, 1. Okay, you guys know this thing. dV is equal to E dot dr. Okay, now this can be Okay, note down the question, guys. Note down the question. This is one of the popular kind of questions that you will come across. How to work around these kind of questions. Okay. So E is equal to E dot dr is equal to minus E dot dr is equal to dV. So E is, how do you define E? Like dV by dr. But what is dV by dr? Dr exists in all space. So you would do a partial differentiation of dV with respect to x, known as I cap minus sign. Okay. So that of you will do, like, you know, plus of dou v by dou y j cap plus that of dou v by dou z of k cap. Okay. Now you always knew about this. From here this comes, that is all you need to know. Even that question where we had you know, x into y combination, I just didn't take it up because, you know, first of all, let's start with something simpler, and then you can write down electric field value. Electric value is going to be, in this case, 2k into 2 into x, that is it, minus, I'm just keeping it out, k I'm taking it out, I'm just doing it from this equation. Differentiate this equation with respect to x. This term will be 0, this term will be 0, only 2x square term will be left over. We will have something like 4x I cap plus of, then we have partial differentiation with respect to y. What would this term would be 0, we would only have left over minus y partial differentiated with respect to y. How much does it give you? Just minus 1, that is it. Okay, here you would have 4x, but here you would have just minus 1. I think there was y square, I guess. Okay, I don't think this was y. I think there was like y square in the question. So this would be minus 2y. Okay, minus 2y. Let me just write it down in the same color. That rest of clarity. Yeah, this would be minus 2y j cap. Differentiated minus 2y. And then the third one differentiated, 2x square does not show up, minus y square does not show up, 0, 0. Then only we have z square left over plus 2z. Now I don't exactly remember the point. I think it was like 1, 1, 1. So this would be minus k into 4 into 1, 4 I cap, minus, again substitute the value of x, y and z. That's it. You need to substitute the value of x, y and z. So this is going to be minus 2 j cap plus, the k cap over here, and this is going to be 2 k cap. Right? Just find out the value. So what do you get? Take out 2 as common. So you would get like something like minus 2. Electric field, right? Magnitude of electric field was asked in the question, I guess. Okay, something like magnitude of electric field or something like that was asked. So this minus j cap plus k cap. So under root of 2 square plus 1 square plus 1 square, that's going to be 2 root 6. If magnitude, if we just talk about magnitude of electric field from this, you can derive magnitude just from this, right? Derive it from over here, and you would get it to be minus 2k, minus would not be there since magnitude minus 2k under root 6. Well, this is the way to go about it. So let's say now this is a simpler case. Just note it down, guys. Note it down. So what was given in the question? Given in the question was you know, like the potential. Some equation for potential was given, and what was asked to find out? The electric field. What did we do? We took minus E dot dr is equal to dV. Then we took differentiation of V with respect to R, which is the same thing. Do a differentiation with respect to R, and then just find out, then partially differentiate dv. dv by dx I cap, dy by dv by partially differentiated potential with respect to x, partially differentiated potential with respect to y, partially differentiated potential with respect to z. Partially differentiated potential with respect to x, we got it as 2 into 2x. We got it as like 4x I cap. And then partially differentiated y square, because x square and z square would not be there, so that would be minus 2y in this case, right? It's minus y square, so it's minus 2y. Similarly for z square, it's going to be plus 2z because x, y, z are not valid. And then what did I do? I substituted the value of x, y, z. Okay, now let's take up the other form of the whatever, like the other question that was given to us. I don't exactly remember the question. I'm erasing this one down, so let me quickly get to the other question. The other question, it's not very much different, guys. It's just a matter of math. Why, I'll tell you, because I'm not even going to erase this two part. Okay, this is going to remain same. What is going to change is this part. How? I don't exactly remember what was given, but I'll give you an example. Let's take up a random example and do it. Now what, it was not k, rather some equation was given to us. So let's take a new equation for potential. Okay. So what kind of equation was given to us? Something like, I don't remember, something like, let's say 2x square y plus of y square z plus of z square z x. I'm just taking a random equation. Okay, random equation. Now how do we work around this? Now what you need to do, you need to move step by step. Step by step, partial differentiation of potential with respect to x, you'll find two terms. One is going to be, I'm just keeping the minus sign outside. You're more concerned about the magnitude at the moment, and now the method to find it out. Okay, I'm just keeping this minus sign outside. With respect to x, first term, yes, you can see something. 4xy, right? Y would not be differentiated, but x would be differentiated. X square, it's going to be 2x, so this will come out to be 4xy. But again, differentiate this. This is going to be 0, differentiated with respect to x. This differentiated with respect to x would give you z square. Okay, very important. So this differentiated with respect to x, what did we get? We got something like z square. Similarly, you will do for the second one as well. Differentiated with respect to y, first one you will get it to be 2x square. Second one you will get it to be 2yz plus 2yz. Okay, everything is changing. Just notice it. How is it all changing? Because when you take a mod, everything would change, guys. Very careful, huh? Very important concept. We'll move on to the electrostatic potential lecture after this. This is a part of electrostatic potential. And what about this? Again, we need to differentiate it. This time it's again partial differentiation. It's partial differentiation. So this is with respect to z. This is going to be 0. This is going to be y square. And this is going to be 2zx. For convenience, we took everything to be at 1, 1, 1. Just substitute it. It's a very simple one now. It's going to look like something like minus 4 plus of 1. So this is going to be like 5 I cap. And this is going to be like 4 plus of, just 4. 2 into 1. 2 into 1 into 1. Just 4 j cap. And this is going to be 1 plus zx. This is zx. 1 plus 2, that is going to be 3 ck. If I had asked you to find out the magnitude, it's going to be 5 root 2, whatever units it is. Okay, 4 square plus 3 square, how much? 25. 5 square 25. So ultimately you'll get it to be 5 root 2 some Newton per Coulomb, whatever, whatever is the value. Simple. This for magnet. This is the actual value of electric. This is your electric. Alright, let's move to the lecture then. Soon, yes, soon, we'll get started, okay? Alright, let's get into the lecture then, guys. And today we are on the lecture number 16 of electrostatics. And before that, let me inform you, the most competitive gamified IIT JEE battle is on. And more importantly, do not miss out today's lecture. We are going to deal with one of the most important concepts that was frequently asked in JEE Advanced. Okay, and that being said, the gamified battle is here, the most gamified, the most competitive IIT JEE battle ever in the history of online education, or take it for any kind of like JEE event. This is going to be Unacademy combat, and not only that, you can win lots and lots of prizes like Amazon vouchers, Apple products, more and more things, like Apple laptop, like iPhone, etc. And in every session there are winners winning multiple prizes. So enroll now with Murli Live code, and guys, it's going to be an amazing battle. So participate in it and win everything that you want. Next event is going to happen on 22nd of October. Sorry, 22nd of November. And that being said, students, yeah, don't miss out on Unacademy combat, guys. It's really interesting, and I had a word with a couple of students as well. They told me it's one of the interesting kind of competitions they have ever seen for JEE preparation. And that being said, students, if you are not yet on our Telegram app, quickly get onto our Telegram app and Telegram channel. So if you don't have a Telegram app yet, just download it from your Google Play Store and App Store by just typing in Telegram, and you'll find it, and then just click on to this link. This link is available in the description box below. You can also just type in JEE_English to find us on Telegram. And what do you get by getting onto our Telegram channel? DPPs, before time updates on every class that is being conducted on JEE English YouTube channel, or any classes that our JEE English team conducts on Unacademy Learning app. So you may want to get onto our Telegram channel. Hi Manjul, hi. Hello students, very good evening. Yes, we are going to get into the lecture part. And that being said, students, if you haven't yet covered units, dimensions and measurements yet, this is the time. Droppers and 12th class students, cover it. I know 11th class students, this is a part of your syllabus. I need not tell you, you will do it. But droppers and 12th class students, do not ignore units, dimensions and measurements. Whatever has been covered in this lecture would give you at least a way to crack 1 or 2 questions in your JEE Mains and JEE Advanced. So this is something that you want to do, and typically this is the easiest topic. All it would take is back to back 3 to 4 sessions to cover the entire thing, 4 sessions plus a 5th model problem session. And guys, let me tell you, this is the easiest topic that you can do in your JEE Mains and JEE Advanced, and the less time consuming one. Very important, less time consuming, not in terms of just preparation, also when it comes to your exam. It's going to be the least time consuming, least confusing, least tricky one. Hence, this is something that you want to do. And it's all available on Unacademy Learning app for free of cost. So you may want to attend it, full-fledged lecture sessions for free of cost, full quality lectures on units, dimensions and measurements. Once you complete these 5 lectures, actually this is 4 plus 1. There is a 5th model problem lecture as well. You may want to complete that also. And yes, post that, guys, you will be thorough with units, dimensions and measurements, everything related to units, dimensions and measurements, error analysis, vernier calipers, screw gauge, everything in one go. And that being said, students, if you don't have Unacademy Learning app yet, download it from the Google Play Store and App Store by just typing in Unacademy, and you'll find us as the first search result. And why do you want to download Unacademy Learning app? The reason is you can attend many such free of cost quizzes, and you can attend free of cost full-fledged quality IIT JEE preparation sessions like what you have seen before. And not only that, guys, we also give you access to Unacademy Combat, the most gamified combat IIT JEE battle ever. So yes, just type in Unacademy, search Unacademy Learning app and click on that install button. And once you have this awesome, Unacademy Learning app, guys, let me tell you, You are going to get access to many free of cost features. Not only that, it's going to be the best thing that you're going to have for your JEE preparation. And that being said, if you're looking for a champion's tool for your JEE Mains and JEE Advanced preparation, it is going to be Unacademy subscription. What do I mean by champion's tool for your JEE Mains and JEE Advanced preparation? It is going to be the best thing that you can have. Why I'm saying the best thing that you can have for your JEE preparation? When you're getting lectures for free of cost on JEE English, what is so different about Unacademy subscription? Okay, Unacademy subscription is not just about lectures, guys. It's about a structured program where you move in a very systematic manner. You get access to multiple programs, unlimited number of programs in unlimited number of languages. Yes. So you will work around your entire thing in a very systematic manner in a structured program. So the programs are generally intensive and extensive. Everything starts from basics and it goes until advanced. So you don't have to worry about anything. You will get full-fledged information on your JEE preparation. Not just information. I mean by information is all the content that you need from the best educators across the nation. So that is the awesomeness of Unacademy subscription. And guys, not only that, you'll get access to leaderboards and dashboards. It's going to be a highly competitive environment, and not only that, it's going to be a very different environment. Students come up with very different perspective of solving the problems. Students understand different perspective of solving the problems, and every fourth session is generally a doubt clearing session. So in a structured program, you also get to get your doubts cleared on time, which is very key for your JEE preparation, and also to become a champion in in your JEE Mains and JEE Advanced. And you get access to national level test series, and every program comes with quizzes and mega quizzes. So think about it, so many things, and unlimited access. Everything is what you get on Unacademy subscription. So if you can afford it, it's the best thing for your JEE preparation, guys. All you need to do is click on the left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal. With this, you'll be preparing for both JEE Mains and JEE Advanced, and then you'll click on the get subscription. Guys, we have the best educators across the nation on one platform, that is going to be your Unacademy subscription. And that being said, students, this all comes at the price of only 70 rupees a day, 2,100 per month, less than 70 rupees a day. Let me correct myself. Less than 70 rupees a day is what you have to pay for this awesome platform where you get access to the best educators across the nation. And guys, do not forget to apply Murlidharan coupon to get to this price point and to avail the best discount. To avail the best discount, to get to this price point, or to get the best discount on any of your subscription purchases, of course, you can apply Murlidharan code. And that being said, this is typically for 9th class students, 10th class students, and 11th class students. So 24 months is the kind of program that you want to choose, since it's a 2-year-long journey, and you will get access to the different kind of programs depending upon your selection. And that being said, students, we also have convenient payment options for you. You can split your payment into multiple parts using our in-house pay in parts option. So this is one of the payment options that we have. This is our in-house option where you need not go through the burden of paying all the fee at once. We also give you access to no cost EMI. If you have access to the no cost EMI kind of cards, etc., you can make use of those no cost EMI cards, and you can avail EMIs at no cost. Again, it's going to be splitting your payment into multiple parts, and you don't have to go through the hassle of paying all the fee at once. So these are two interesting payment options. You also have other traditional payment modes like debit card, credit card, UPI, etc. And that being said, students, if you are in long term and dropout, 12-month program is for you, because we have dedicated programs for your preparation. And this also goes for 12th class students who are only aspiring to prepare for 1 year. So 12-month program would suit you, and we have 6,000 plus recorded materials, 7,000 plus recorded materials for JEE preparation, and also 1,000 plus live programs right now going on, so that you can learn from the best educators across the nation. And guys, this again comes at a very economical cost of less than 2,900 per month. All you have to pay is less than 2,900 to get to this to get access to this awesome platform. And do remember, it's one subscription, unlimited access. I'm saying this especially for long-term and dropout students, because you know what, we have dedicated programs going on for your JEE preparation. Let's say you have backlogs on optics, you can start attending optics. Let's say you have backlogs on waves, you can start attending waves. And yes, students, do not forget to apply Murlidharan coupon to get the best discount on your subscription purchase. And that being said, the optics basics to advanced coursework is on Unacademy subscription platform. If you're already on Plus, enroll to this course. Why you should enroll to this course? It's a comprehensive course on optics where we'll go from basics until advanced. So every small topic around optics will be covered. And comprehensive course, by comprehensive course I mean we'll be covering both ray optics and wave optics. And guys, this is the time to attend it. It has just been launched. We are getting into, you know, a very interesting part of optics, so you can start attending the course right away, or from tomorrow right away you can watch the recorded videos, so you can get started in a way. And try to maintain completeness, try to cover each and every lecture. Do not even miss out a single lecture. That is very important for your optics preparation or any subject. Electrostatics, optics, current and electricity, try to maintain the completeness. So that is the key part of it. And yeah, we are going to cover anywhere around, you know, like 600 and odd model problems in these sessions. Like, you know, 300 to 600 odd model problems, and we are going to discuss anywhere around 100 plus concepts in these awesome, you know, optics basics to advanced session. So yeah, that being said, our team is also, the JEE English team is also on Plus. So we have started courses on optics B to A, you know that, and we have courses on differential calculus, electromagnetism and chemical kinematics as well. And guys, for 2022 aspirants, we have launched courses on graph sets and relation. We have launched courses on redox and equivalent concept and mechanics, guys. And that being said, practice, practice, and practice only makes you perfect. Of course, today is IPL final, but you want to practice here and you want to learn better things. This is the time, guys. Start practicing electrostatics. You still have time for your JEE Mains and JEE Advanced preparation. And let's get started with the first question of the day. A very important concept, guys. A very important concept. Again, I'm taking it from a problem perspective. I know this is a problem, but you know what, we'll take up more similar problems in the upcoming session, since it is one of the most important part of your electrostatics. But from this, we will derive something amazing, something interesting going forward. Until now, whatever you have seen in terms of derivation, you must have had a lot of confusion, but we will derive something interesting at the end of the session. Not right now. Right now, we are going to start with some problems. So get started on the problem, and you'll notice something very interesting. So two spherical shells of radius r and 2r have same charge plus q distributed uniformly on the surface. Okay. The ratio of the electrostatic potential at the surface of smaller sphere to that of the larger sphere with radius 2r. So there are two spheres, basically two concentric shells, basically in this case. And now in this case, one of the shells have a radius r and the other one has 2r. Now each shell have plus q charge uniformly distributed on the surface. Now what are they asking you? What is the electrostatic potential on the small shell and on the top to, actually the ratio of the electrostatic potential of that small shell to that of large shell? You basically have to find out electrostatic potential at the small shell and then at the electrostatic potential at that of the large shell. So how are you going to do this problem? Think about it, whether it should be 0, whether the electrostatic potential is going to be same. You think the electrostatic potential is going to be same, or whether they would be in the ratio of 2:1 or they would be in the ratio of 3:2. A very important concept. Get started. Alright, let's get into this question then. It's a very simple question. First of all, let me ask you something. I need to find out electrostatic potential at this point. That is on the small shell. We are talking now about on the surface of the small shell. We have two spheres. Let's label the sphere. Small one as S1 and big one as S2. So for S2, it is at some point inside that shell. So potential, there will be two kinds of potential. So in such problems, what will you do? You'll keep adding the potentials, right? So in this case, let's say potential at this point, let's keep it as P. At point P would be due to potential due to sphere 1, small one, plus that of sphere 2, the large one. Sphere 1, what is the potential? Sphere 1 potential, we know it's going to be KQ by R. Hi Brijesh, hi. And what about the second one? Now the interesting part in this is the second one. For second one, what is this? What is this point for the second one? For second one, it's a point inside the shell, right? Answer is not A, right? Why it would be A? Alright. So yes, Brijesh, focus. It's a very simple one, guys. For the second sphere, we are talking about this sphere. It's just a point inside that sphere, which is going to be like KQ by 2R. Right? This is due to. First one is simple, so you know it. So now what is the total potential now at this point? Let's carry forward this equation, just add it up. So you'll get something like, 2R you need to make. So you'll get something like 3KQ by R. 3KQ by 2R. So now at this point P, what is the potential? 3 by 2 KQ by R. We have 1. Okay, very good. Now what about on the surface of the larger sphere? On the surface of the larger sphere, let's call this point as something like PQ RST. Okay, let's call this point as something like O. Okay, now what is the potential at O? There will be two kinds of potential. Carefully. One due to sphere 1, of course, other due to sphere 2. Sphere 2, it's very easy. For sphere 1, what it is, so let's define them individually. For sphere 1, I am dealing with which one? The small sphere. Due to small sphere, there would be a potential. Due to small sphere, what is the potential? KQ by 2R, isn't it? KQ by 2R. This is the shell concept, right? This shell, at some point outside it, what is the potential? It's going to be KQ by small r. In this case, what is the small r? 2R, right? At this point, it's 2R. So it's going to be KQ by 2R. Let me KQ by 2R. Now we need to find out potential due to S2, which is very simple. Yes. Okay, what's your question? So it's going to be KQ by 2R again. Why? It's on the surface. It's going to be the same as the earlier one due to sphere 2. Okay, basically on the surface. So if you have noticed something, you'll notice something very interesting at the end of the day. Okay, so how much this should be? This simple, right? Again, let me tell you. Okay, good. So guys, I hope you understood it. Yeah, I'm repeating it. Okay, at this point, what is the potential? One potential due to sphere S1, which is going to be KQ by 2R at a distance 2R from it, just like a point charge kept at a distance 2R from it. And what about due to sphere 2, the larger one, it's on the surface, it should be KQ by its radius. In this case, the radius is how much? 2R. So it is going to be KQ by 2R. Okay, that is it. So what is total potential now at this point O? Point O or something on this larger sphere. So it was due to Vs1 plus of Vs2. So we would have something like, I'm just going to keep it as by 2R. I'll tell you the reason why. So it's basically KQ by R. If you add them both, you'll get KQ by R. You have to add them both. I have reason for that. because we are going to basically divide one by other, right? We need to find out the ratio. So one was at this point O and one was at this point P. Right? This point. Now we had the potential Vp is equal to 3 by 2 kq by r. And now due to this point VO, there would be 2 by 2 kq by r. Now Vp by VO, how much is it? Let's take the ratio. It's a very interesting concept, guys. Vp by VO was what was asked. Going to be 3. This part and this part would get cancelled out. Basically 3 by. That is it. Easy? Alright guys, I believe this was a simple concept and I think the answer is D. I think I got the answer to be D. Alright, the earlier one is D. Okay, don't worry. Alright, let's move on to the next one then. So, let me ask you a question now. So, if charge Q is given on a small sphere and a charge Q is given on a large sphere, what is happening? The potential at the surface of the smaller sphere is greater than that of potential on that of larger sphere. Now, this is a different case. Look at it carefully. Okay. Now, this is what is going to give us the foundation for the derivation. So, very carefully, students. Okay. All right. No worries, guys. Yeah, notice the thing. Okay. Now, this is not Q distributed on it. Two spherical shells of radius r and 2r have same uniform charge density sigma, surface charge density sigma on them. Then the ratio of electrostatic potential at the surface of that of small shell to that of large shell is how much? Are you sure it is A? Start solving it. Start solving it, guys. Start solving it. It's very easy. Put that pen on the paper. Okay. It's of course not B. Let me give you the hint in the beginning itself. Okay, there it was 3:2, right? Yeah. Of course not B. I'll give you that hint. So start solving it. It's a very easy question. Once I solve it, you'll say it was damn easy. But this is something that you need to understand before we get into the next concept. So do it. Okay. Do it, guys. Do it. It's a very simple one. Alright, let's get into the question then. So let's get started with the usual thing. We will have to label 2 points. One point is going to be O, other point is going to be P. We are going to get started with O first. So smaller shell is what we are concerned about. So two potentials, one due to S1, one due to S2. But before this, let me quickly intimate you a few things. Charge on sphere S1 is how much? Sphere S1 is how much, guys? Sigma into area. This is going to be sigma into, let's keep it as A1, okay? 4 pi r square. What about charge on sphere S2? Going to sigma into A2. Right? So that should be how much, guys? Sigma into 4 pi into 2r square. Very important thing. This is where entire game lies. That is it. These two things is something that you need to know. Rest is just S1, S2, VS1, VS2. Same thing, nothing changes. Okay, this is just to observe something new around it. Okay, so again let's move into it. So you understood they will not have same charge. There would be some charge Q1 on this. There would be some charge Q2 on this. I'm going to call this as surface 1, the surface 2. Now potential due to surface 1 at point P. We're talking about point P. What is the potential due to surface 1? Due to surface 1, there were two potentials, right? One due to inside, one due to the other one. Okay. Due to surface 1, it's going to be like KQ1 by R, radius of this sphere, surface potential basically. But if you substitute the value of Q1, you'll notice something very interesting. For now, let's keep it as Q1. Okay, let's work around it. Let's find it. Sigma into 4 pi R square divided by R. How much do you get? Take out this 4 pi K into sigma into R. Okay, I'm just going to ever keep this 4 pi K sigma because we are going to see 4 pi K sigma. Okay. Next, due to surface S2. Due to surface S2, surface potential again. So it would be just like how we did in the earlier case, KQ2 by 2R now. So at some point inside, same as at the surface, right? It's going to be KQ2 by 2R. And how much is this going to be? K into sigma into, notice the thing carefully, it's 2R square. Not R square, but rather 2R square. So guys, do not go wrong over here. That means you have done the basic math wrong. So again, I'm going to take out 4 pi K sigma as common for both because ultimately you are going to add them. Then you'll have into 2R. Okay. I think we are just falling short of space. So let's keep it as 2. Alright. So total potential at point P is how much? Vs1 plus Vs2. Point P. Point P, we have two things, which is going to be Vs1 plus of Vs2, which we are going to get it as K. Okay, we are not doing the entire calculation again. I'm just going to add up both these terms. And what did we have? We had something like 4 pi K into sigma into R. I'm taking this common, guys. Actually, the term was something like this. We add 4 pi K into sigma into 2R. Just take out 4 pi K sigma as common. 4 pi K sigma R plus 2R. That's going to be 3R. Just keep it like this. Finally, you will realize something amazing around this concept. Okay. Alright, just 3R. I'm just going to keep it as it is. I'm not going to, move this here and there because we have something interesting around this concept. Alright, now using this, what are we going to do? What are we supposed to do now? We need to find out for point for here. Okay, so we have another point here. Point, let's call this as O for now. Okay, this is O, not P. Let me just quickly. So do you think now the potential on surface 2 is going to be greater or on the surface 1 is going to be greater, guys? Which one is going to be greater? I believe again surface 1 is going to be greater, isn't it? Let's check it out. Let's check it out quickly. Okay, which one should be greater? Now two potentials, of course. One is going to be due to surface S1. Now what is the potential due to surface S1? Let's call charge Q1, Q2 as we did earlier. It's going to be KQ1 by 2R. And due to surface S2, it's basically surface potential. So it's going to be KQ by, again. So this is going to be surface potential KQ2 by 2R. That is it. Now, what is total potential, guys? It's going to be K by 2R into Q1 plus Q2. Something interesting, huh? Now let's move on to it and let's simplify it. It's a very simple problem. If you notice it, it's a super simple problem, guys. Alright. Now VP at this point P. VP, how much is it? We found it out to be K by 2R into Q1 plus Q2. So this would come out to be like how much? We need to write down the value of Q1 and Q2. That is when we'll come to know the sigma into 4 pi R square small r due to this one charge present on it. The second one is going to be sigma into 4 pi into 2R square. Right, that's it. Now you need to add them both and you'll come up with some value. Let's see, we have some space. Yes, we have some space. So it's going to be like we can take out I can quickly write it down over here. We have some space. So we can take sigma 4 pi common 2R. Just don't cancel out anything because we will finally have to simplify it and solve it. Try to hold on to the common terms ever, okay? Anytime you're doing it in physics, especially for your JEE Mains, JEE Advanced, try to hold on to the common term. Okay, so let's get on to the next one. Then VP is equal to we had something like, let me just quickly grab it, guys. So this is the common term 4 pi K sigma, which you don't want to ever disturb, because if you disturb this, ultimately your entire calculation will become lengthier, at least lengthier in terms of while you're doing it in an exam, etc. Right? It's going to be lengthier. Yeah, of course it's going to be lengthier because what is asked is ratio, and we have something like by 2R into 2R square plus 2R whole square plus R square, which is going to be 5R square. Simplify this, what do you get? VP to be something like 4 pi K sigma 5 by 2R. Right? 2R square, expand it. How much do you get it? You get it to be 4R square plus R square, 5R square divided by 2R. It's going to be 5R. Second one also you got. Now take the ratio. It's a very simple problem. It's no more a very challenging problem. So VP, how much do we have it as? This is the point P. We have it as 4 pi K into sigma into 5R by K. Then we have potential on the smaller surface, which is like, if this is P, we call this to be P. Let's call this as P dash for now. Okay, we had defined 2 points, P only. Let's call this to be P dash. VP dash is equal to 4 pi K into sigma into 3R. Right, take a ratio of them. VP dash divided by VP. How much do you get? This gets cancelled out. Okay, let me do it with the color, some kind of color. So this would get cancelled out. What is left over? RR gets cancelled out. We have something like a very interesting result. I'm going to write it down. 3 divided by 5 by 2. What it is? 6 by 5. Still, even in the case of uniform distribution, this is surface 1, surface 2, and the potential of surface 1 is greater than that of potential of surface 2. The potential at the surface 1 greater than that of potential at surface 2. A very interesting result. Answer should be 6 by 5 anyway. For your calculations, answer should be 6 by 5. Okay. Alright, I believe let's do a thing. Let's take up rest of the problems tomorrow, because I guess it's already late for many of you. has become a lengthy lecture along with the quiz. But try out this question, and the question that I would like to pose to you in terms of this question is like, okay, let me first of all explain this question so that we don't have any SL around the tomorrow's like concept. But the thing is, what students cover today's concept, completely try to understand what did we do. We added up the potential, outer shell's potential, inner shell's potential, anywhere at any surface. Inner surface, outer shell add the same potential as surface potential. Okay. Now we are going to get into a very different concept where we have a non-conducting sphere and it has charge plus Q uniformly distributed throughout its volume. Electric potential at its center is. So do you think electric potential is going to be 0, or it is going to be the same as surface potential, or is it going to be some other value? Think about it carefully. Make use of that shells, you will get a very interesting result. That's all you need to do. You need to understand it from the shell's perspective. Super easy, guys. Alright, so you must have come across different kind of derivations, etc. if you have done it earlier. If not, stay tuned, it's going to be super easy concept. Right, we will take up another such problem. And that being said, students, the most competitive gamified IIT JEE battle ever is on. Already one has been completed on 8th of November. A lot of students have won Amazon vouchers, Apple products, etc. So start competing live, and you can also win Apple laptops, iPhones, many more things, and also like up to I think 100 Amazon vouchers. So next session is going to be post your Diwali on 22nd of November. Enroll now and do not forget to apply Murli live code. So you enroll to this Unacademy Combat, guys. That's very important because it's going to be a very competitive environment, and more importantly, you will have a feel of a competition, guys. A competition where you can win some real prizes. Amazing thing, isn't it? Check it out. And that being said, students, if you're already on subscription platform, right away enroll to Optics Basics to Advanced course, Optics B to A course, where we are taking everything from basics until depth, so that you don't have to miss out any concept. And let me tell you guys, we have just begun the coursework. You can still enroll to the coursework. It's going to be very interesting. So we had a couple of questions today. If I'm a 2021 aspirant, 2022 aspirant, should I be attending optics? Yes, because it is independent of rest of the topic. And here you don't require any prerequisites. As such, for optics, you do not require any prerequisites, or it does not have any connection with the rest of the topics. But let me tell you guys, Optics B2A coursework is one where I'm taking you from the basics until advanced. It's going to be super easy. You are going to face JEE advanced level problems even if you don't know anything. But get started today. Enroll soon. Try to attend the daily interactive classes where you can interact with me and ask me doubts. And that is going to be super interesting, guys. And yes, it's a comprehensive coursework. In this, we'll be taking you from ray optics until wave optics. So it's a complete thing. We will be having 60 plus sessions on just optics. So think about it. We'll be discussing 120 to 150 plus concepts, 300 plus model problems, and it has all just been launched now. So time to attend, guys. If you're planning to purchase subscription, this is the time. Enroll now, guys. So if you're planning to purchase subscription, purchase it and enroll now. And that being said, I wanted to take up a question from one of the students. So just give me a moment. So we had a question last class from Suraj, I guess. I'm just going to have a look at this question again. So just give me a moment. So before we jump into tomorrow's lecture, before we jump into tomorrow's lecture, what is going to happen, etc. We need. I'm going to take up quickly his question. Okay. So his question was something like this. So Suraj had asked a question. So I saw in an example question of constrained motion, it was asked to find out the velocity of a block which moves on the horizontal surface as a string attached to the block is being pulled. Okay. And the string makes an angle theta with the horizontal. So let's say the velocity of the string is VA and that of the block is VB. Now my doubt is which among the following is correct. VA is equal to VB cos theta or VB is equal to VA cos theta. This is my doubt. I understood your question, Suraj. I was about to bring up the screenshot, but I thought, we also have other lectures going on. So I did not bring it up. So here we go. Okay, let me choose a good color. Take up maybe. So we have a block. This block is on a stationary surface. Okay, what are you doing is this block is completely touching the ground now, okay? Anyway, it's a frictionless stationary surface. What you're doing to the block is you are attaching a thread, a string, and the string is being pulled at velocity how much? VB, I guess. At a velocity VB. And block is moving in the horizontal direction with VA. Okay, and it is given that this string is making an angle theta. Suraj, this is the question. So how do you work around this? This is your query, I guess. See, first of all, you asked me which one is correct, whether VA should be equal to VB cos theta. So I see this kind of issues in really even sometimes in reputed books. The reason is you miss out a very small thing, guys, and that small thing turns into a very big confusion, especially for students who are just starting out. It becomes a huge confusion. Many times your solution will be justifying the entire thing. Okay, so your question is whether it should be VA is equal to VB cos theta or VB is equal to VA cos theta. Okay, let's move in two approaches. One is your resolution of components. So if you resolve the component, and I'm not talking about a vertical velocity, what is the velocity along x direction? So it's going to be VA would be like VB cos theta. You resolve this into two components. We need to resolve VB into two components, not VA. So one would be like VB cos theta. This is also theta. And one would be like VB sin theta. We are assuming mg is so good, huge that it's never being lifted. So yeah, so what it should be, VA is equal to VB cos theta. And whenever you get a doubt like this, simply do something like this. It often happens, you know many things till you get a doubt like this. So among these two, one says VA should be less than VB. The other one says VB is greater than VA. Right? VB is greater than VA. Okay, just a moment. I think I made a small mistake. Greater sign. I have confused. So anyway, this says VA is equal to VB cos theta. Cos theta is always less than 1. That means VB is always greater than VA in this case. And in this case, VA is always greater than VB. Okay. So now, according to your question, Suraj, so this is a question by Suraj, a really sincere student who often comes up, actually a very smart student. I've seen him answer, like current electricity questions and all. So whenever this kind of, confusion comes up in your mind, simply think about it like this. VA can never be greater than VB. Velocity of the block can never be greater than VB. Simply never ever get this doubt in your mind. It often happens, you'll see in rotational motion, somewhere it is rotating, suddenly it will be justified, that point is rotating at a slower speed than its vertical component. No, never ever that happens, right? Always VB is greater than VA. Hence, without any doubt, you can proceed VA is equal to VB cos theta. But anyway, resolve the components, a basic thing. But ever if you get it out like this, because this is a basic thing where you got this doubt, that is fine. But what if you're coming to a question like where laser is rotating, etc. I've seen a question like that. There you would get confused. Don't do that. Recently, we have done a question, one such question, the optics course. Okay. Alright guys, and that being said, do not forget to share this video, do not forget to like this video, do not forget to click on that subscribe button and bell notification to get timely updates. And students, yes, do share this video, do like this video, and work hard and smart to achieve your success. Keep acquiring knowledge, but at the same time share it so that you can double your knowledge, because you'll start brainstorming with your friends. Also, do not forget to share this on all these possible social media, like your Facebook, WhatsApp, Telegram, whichever thing you have, guys, because it's a free of cost initiative and academy where you are getting not just free of cost but quality lectures for your JEE Mains and JEE Advanced preparation. And that being said, students, if you don't have a Telegram app yet, download it from your Google Play Store and App Store, because you want to click on to this link which is available in the description box below. Why do you want to click on to this link, and what would happen once you click on to this link? Guys, you will get on to our JEE English Telegram channel where you will get on time, before time updates on every lectures that are being conducted on, like JEE English, or also by any of our JEE lecturers, JEE English lecturers on Unacademy Learning app. So this is that one place where you would get before time updates. It's like clicking that subscribe button, but even better, sometimes we post with updates, etc. But yeah, maintain both so that you get like live notifications over there as well, and over here you will get before time updates and you can plan accordingly. So yes, click on to this link and get on to our Telegram channel. You will get access to so many things, also like challenge problems, etc. And that being said, students, if you haven't yet started units, dimensions and measurements, if you are partially completed and if you are looking for a completeness, you may want to attend my series A to Z series on units, dimensions and measurements, where we have completed everything on units, dimensions and measurements, guys. Why units and dimensions and measurements? You know it because it is the easiest thing that you can have for your JEE preparation. Of course, it's a cakewalk, and this cakewalk comes in within like 4 sessions of like by attending 4 sessions. All you need to do is you need to attend 4 sessions from 19th September to 22nd September, and there you go. You have completed most of the model problems and all the theory around units, dimensions and measurements. And there is another 5th session. If you complete that, you have totally completed everything around units, dimensions and measurements, and you definitely get 2 to 3 questions combined in your JEE Mains and JEE Advanced. And definitely, you notice your JEE Mains paper, there isn't a paper without dimensional analysis. And similarly, try to notice JEE Advanced paper. Typically, you'll see a question around units, dimensions and measurements. In this, we have covered everything, like error analysis, vernier calipers, like dimensional analysis of so many quantities and different kind of unit conversions, so many model problems. So try to attend the 5th session as well. And guys, especially if you're a dropout or a long-term student, do not ignore this topic, because not only it's easy, it's less time taking, it will also take less time in your JEE Mains and JEE Advanced exam. So try and attend this, this 4 to 5 lecture series, A to Z lecture series on units, dimensions and measurements. You can also start attending many more lectures of A to Z. Recently, we are on capacitors, so try to cover them as well. Along with electrostatics, they go well, I mean, like they go hand in hand with electrostatics, and they go really well with electrostatics, guys, because electrostatic potential, from there you will drag on to capacitors. But I took capacitors earlier than that of electrostatics, because sometimes you get your questions from current and electricity and capacitors. So that way I thought about it and I took the course. But now you can start attending it if you are starting with electrostatics. And we also have recorded lectures of current and electricity A to Z series on Unacademy Learning app, all for free of cost, guys, all for free of cost. So yes, these lectures are of free of cost. So to attend these lectures, download Unacademy Learning app from your Google Play Store and App Store. All you need to do is type in Unacademy, and the first search result is going to be Unacademy Learning app. Just click on to this and click on this install button, guys. Once you install it, of course you can attend from web-based version, but once you install it, you will get live notifications once you start following me, guys. So that is the amazing thing about Unacademy Learning app. You will also get live notifications, and you can attend so many such free of cost special classes. And guys, you also get access to amazing things like quizzes, where you can expect to where you can expect to attend questions like your PYQs and model problems that you can expect in your exam. And for even Unacademy Combat, you need Unacademy Learning app. So do not hesitate to click on this install button, the most downloaded learning app. And guys, we are impacting near about 7 million lives a day. And that being said, students, if you are looking for the best thing for your JEE preparation, I mean, if you're aspiring to become a champion, and if you're looking for a champion's tool, and especially for your remote education, it's going to be Unacademy subscription. So what do you get in Unacademy subscription? The best educators across the nation teach on Unacademy subscription, guys. Yes, the best educators across the nation work for your goal, and you will attend the daily interactive classes with the best educators across the nation in a structured manner. What do I mean by structured manner? It's going to be not just lectures, but an intensive and extensive program where you'll be attending not just lectures, but you'll have doubt clearing session, quizzes, and mega quizzes. So it will be in a very structured manner. Everything will be from basics until advanced. Everything will move in a very structured manner. And of course, guys, it's an amazing experience to have it on that environment. And you also get access to leaderboards and dashboards. And the best thing about Unacademy subscription is you're attending it on a platform where you will get experience of your JEE Mains and JEE Advanced exam, like the environment of JEE Mains and JEE Advanced exam. Not only that, on Unacademy subscription, we keep conducting national level test series, national level quizzes, national level mega quizzes. This way you get to assess your competency, and you can work around your strengths and weaknesses. So this is the awesome thing of Unacademy Learning app, and all you need to do is click on the left hand top corner extension bar and choose plus as your goal, and then choose IIT JEE as your goal. And then you will click on the get subscription button. And guys, the amazing thing about Unacademy subscription is one subscription, unlimited access. You can access unlimited number of programs throughout that period. Yes guys, that's the amazing thing about Unacademy subscription. And we also have legends like DC Pandey sir on this platform. And that being said, students, the subscription is not going to cost you much. It comes at a price of less than 70 rupees a day. And that is 2100 per month. But this is a 24-month program, typically meant for 9th class, 10th class, and 11th class students. And guys, yes, it's economical and the best thing that you can have for your JEE preparation. Do not forget to apply Murlidharan coupon to get best discount on your subscription purchase, and to get to this price point, guys. Yes, and that being said, you know what? You can split your payments into multiple parts using our pay in parts in-house feature. This is our in-house feature where you don't have to go through the burden of paying all the fee at once, and you can typically split your payments into multiple parts. And yes, you don't have to take that burden. And we also give you access to no cost EMI. We have access to no cost EMI where you do not have to pay any interest on your subscription purchase. Hi Ananya, good evening, good evening. I hope you have attended this class. If not, do attend it. And Ananya, do not miss out tomorrow's class. Tomorrow we are going to deal with the most important part. According to me, this is one of the most important part on electrostatic potential, because this is one of the places where most of your questions came in your JEE Mains and JEE Advanced. Okay, this is the foundation. Okay, any different kind of problem is given to you, how would you solve around it? So the typical methods that you're dealing with, in your NCERT books, etc., will fail at some places, but it will ultimately give you the correct answer. That's a different thing. But the thing is, we will derive the most accurate way to calculate those kind of electrostatic potential. So make sure you're attending tomorrow's session. Hi Ananya, hello. So cover today's part so that you get an understanding of that, superposition of the potential. You can directly add up the potential. Okay. If it is negative potential, you would subtract it, guys. In that case, if one of the shells was negative, you will subtract it. If one of the shells was of the opposite charge, of course, you're going to put that negative sign. Do not forget to do that. And guys, yes, we have convenient payment options for you where you can split your payments into multiple parts and you don't have to go through the hassle of paying all the fee at once. Yes, that is going to be pay in parts option. We also give you access to no cost EMI where you don't have to bear any interest on your EMIs. And we also have other traditional payment modes like debit card, credit card, UPIs, which you can check out. And guys, if you are in long term and dropout, this is the ideal program for you because you know what, 12-month program suits really well for long term students and dropout students, and also students in 12th class and aspiring to prepare for only 1 year. And guys, the thing is, we have dedicated programs for droppers batch. We have dedicated plus courses going on, just like optics basics to advanced, and we have 7,000 plus materials for your JEE preparation, 1,000 plus live programs going on just on JEE preparation, guys. And yes, if you're a dropper, this is the time to get started. Even if you have any concerns around dropping, etc., you can get started now. Start early. This is the time, guys, and this all comes at the price of only less than 2,900, at the price of 2,888 only. And how do you get to this price point? You apply Murlidharan coupon, you avail the best discount. Do not miss out any discount on your subscription purchase. So apply Murlidharan coupon, do not miss it out. And that being said, students, yes, see you in the next session with more interesting concept. And tomorrow we'll be solving something very interesting. You will understand the method to do, how to find out electrostatic potential at the center of a non-conducting sphere. That is where we'll begin. We'll move on to more advanced problem. But the way that we are going to learn tomorrow is the way that you want to probably apply throughout your life, or in your JEE Mains and JEE Advanced exam. Of course, you are going to take a different approach than what you have been learning in your NCERT books, etc., because there is an issue of at least there can be some confusion. So we will take up the correct method of doing it, and yes, you can use it for even non-uniform non-uniform charge distribution, etc. Okay, so learn that method, apply it, and not only that, we'll take up more advanced problems tomorrow. See